Hello, I'm Cheng and I'm a computer science PhD student at Arizona State University. My research focuses on computing education and educational data mining. This is one of my projects in collaboration with my advisor, Dr. Hsiao, about the use of augmented reality for computational thinking. I'll start with a brief introduction to the background of this research, and then I'll describe what are the immersive experience and the connection to education. It is followed by the design and assessment plan in method. Then I'll present our evaluation results in findings. This work consists of two components: augmented reality learning experience and computational thinking. On the line of AR learning experience, we follow the work from Santos, who reviewed AR applications for science, technology, engineering, and mathematics back in 2014. From this line of work, we summarize that the benefits of AR include the support of exploration and simulation, allowing natural interaction between content and users, and contextualization of learning topic. On the other side of our work, we focused on computational thinking. So over a decade, there have been a lot of research focused on teaching computational thinking to not only students from different domains other than engineering, but also younger learners. However, the format of learning or teaching computational thinking is still largely constrained by the use of desktop or laptop computers. Our work is therefore aimed to borrow some experience from AR learning experience and think about whether we can design or make different kinds of learning experience for computational thinking. Although there have been many AR applications, and some of them are related to computing education, there is still one critical question which has been asked for a long time. Does AR visualization can really bring in any benefits to student learning in terms of computational thinking? To the best of our knowledge, there is still very limited or few evidence in terms of computational thinking. So this work is therefore aimed to fill this gap by asking these two questions. How does AR visualization affect performance and communication in a debugging task? And how does AR visualization support algorithm design in a debugging task? The reason why we chose debugging task as the major topic is because that in a lot of computational thinking frameworks, most of them suggest that debugging is one essential topic and a core component in computational thinking because it is comprehensive and usually involve multiple concepts in the practice. So what is the immersive experience in our work? I quote the term immersive here because sometimes people believe that immersive has to be connected to virtual reality experience. We follow the definition from Date about this immersion. So there are three kinds of immersions here: sensory immersion, symbolic immersion, and actional immersion. We acknowledge that AR learning experience or our application can only provide very limited sensory immersion due to the hardware or software limitation. And our application focuses more on actional immersion and symbolic immersion. In terms of actional immersion, our AR version allows the user to change their point of view. So you can see on the left-hand side, it's a snapshot of our AR application. The user, when they are using this version, they can change their point of view and to obtain more depth information. For the non-AR version on the right-hand side, they are only allowed to view from a fixed angle. And such an experience matches the definition of this actional immersion. Our application also promotes the collaboration among two users. So as you can see from this screenshot, the two students, they view the same content from different angles. So they are able to obtain more information from the map compared to the non-AR application. And we use a special synchronization mechanism to ensure that these two students will collaborate with each other to some degree. And we will describe that mechanism more in a later section. So there have been many tools for learning in computing education or computational thinking. The connection of this work to education is that we try to provide a different way to design an instruction for the learning of computational thinking. So think about that. Nowadays, there have been a lot of museums, they try to use augmented reality, virtual reality, or mixed reality to engage their audience in the content. Nowadays, it's a society surrounded by a lot of different technology. And we believe that AR has the ability to connect our daily life in the learning in these computing technologies. So we try to provide a possible design of collaborative AR learning experience for computing content. We also try to provide some empirical evidence that such an AR experience can support students to perform better or engage students in the content. Our research is based on two frameworks. One framework from computational thinking and the other one from AR learning experience. And you can see from this chart how we connect these components together. And to measure the student's performance or the effectiveness of AR, we try to use two factors, the co-editing and communication. And we also employ this special synchronization mechanism. So when the two users are working on the task, they will have the impression that they are working on the same program. And in order to make the helicopter capture everything, the two users have to negotiate or collaborate with each other regarding how they want to design this program and what they should do at each step. We conduct a within-subject experiment with our novice students at ASU. Here are some screenshots from our experiment. The left-hand side is a pair of students that try to use the AR version, and the right-hand side is how the user will use the non-AR version. So in our analysis, we found that the AR group, they had a more effective co-editing pattern and higher performance than non-AR. At the top, you can see that the error rate of the AR user is significantly lower than the non-AR group. At the bottom, it shows the co-editing pattern of the AR and the non-AR, and we can see the AR group, they had more concentrated and more effective co-editing than the non-AR group, whose co-editing pattern is more diffused. And we also found that the AR group, they talk more with their partners compared to the non-AR group. We think this is evidence showing that the AR engaged students to some extent. One thing to note here is that these outcomes have to be interpreted together with the content design. It is possible that it is the design of our content that makes the difference between AR and the non-AR group. Because there's no universal standard when people want to design the AR experience for different learning content, we encourage our listener or our reader of the paper that when you try to interpret such a result, that you need to consider how the researcher designed the content. And we have some discussion in our paper that you can take a look if you want to know more about the connection between this content design and the effective outcome. To conclude, this research tried to provide some preliminary but empirical and quantitative evidence about the effectiveness of AR visualization for the learning or the practicing of computational thinking. But of course, more analysis have to be done regarding the semantics and the algorithmic thinking. We put this part in the future work, but actually we have already done this analysis just at the moment that we finished our paper. We hadn't been able to include those parts. But here is some result from that part. We also found out that the communication in the AR group was more interactive than the non-AR. For this part of analysis, that we encourage you that you can follow us in our website, or you can check out our follow-up research papers at a later time. If you have any questions, that you can contact us through this email, or you take a look at our project page for the follow-up research about the semantics and the communication detail in the AR experience for computational thinking. Thank you.